All right, how do we defend against SQL injection? And again, get your web app developer and your database administrator in on this. First of all, make sure that your web app developer learns safe coding, that they develop a web app that will always validate input. Make your database administrator create stored procedures in the database to enforce correct input and disallow ad hoc queries. You see, a stored procedure is already a SQL query that's pre-written, and you just plug in very specific things. And they don't allow you to plug in just stuff that goes on and on. So you want to use stored procedures and have the web app use that. So when we do input validation on the web app, and we have stored procedures that don't allow any nonsense on the database side, now both camps are working to defend against SQL injection. Use prepared statements with parameterized queries. That's these stored procedures I'm talking about. Use whitelist input validation, and we're going to see an example in a moment. Escape all user-supplied input. In other words, treat it only as text. We use special characters. Ensure that the database service account has minimal rights. It's not like a domain admin. So here's an example of unsafe code. You don't need to be a coder at all. I just want to point out one thing right here. So we're creating a query. It's a string. And the query is select the account balance from a table called user data where the username is, and I don't know what. You add that, you have this. So plugging right into here, and this little thing where the username is not, you have this, you add, you concatenate. That's this little plus sign. And you have this little thing called request.getParameter, and then customer name. Now, here's the rub. Customer name is assumed to be like you see it, customer name. There is nothing in this code that says customer name has to be only letters and a certain length and maybe a couple of extra characters. There is nothing to stop when we enter a customer name, because what we're doing is we're entering a customer name. There's nothing to stop us from entering whole paragraphs of stuff in here. That's the risk. And this is just part of a try-catch statement to try, and then if there's an error, handle it. But that's not the part we need to worry about. It's the fact that you're going to enter a customer name here, and there's nothing stopping or saying what that input has to be. So that's unsafe code. In Java, this would be a prepared statement where you have predetermined some things. This is just one example, not trying to teach you Java per se, but just so you can see an example of this. So we are saying that there's a string, it's called customer name. And it is make a request, get the parameter customer name. Okay, so far that's fine, although we should really validate that as well. But we're not done. Now let's add some input validation to detect any attack. So we have a string called query, and we say select account balance from user data where username equals, and then we have this question mark. And then we create this prepared statement. We give it some kind of name. And it is a query, or we use this query right here. And the statement is just one, cust name, and cust name means it is this here. What we're trying to say is you are limited, just one customer name here. You can't just be putting in whole paragraphs. And then go ahead and execute. Here's an example of a safe stored procedure. And again, we have this get a parameter called customer name. And we have a try-catch statement, but what we have here is we're creating this procedure here, and we're saying in the connection, make this connection here, create a stored procedure called get account balance. And in this get account balance here, we're basically saying the string will be one customer name, get the result, and pass it over. And so we already are specifying how to get the customer name without allowing loads of weird data or weird input to come in. Here's an example of whitelist input validation. You can use like the case statement, which means if this exists, case. So supposing this is so, supposing it's so that the value table name is some table, okay. Or if another value is table name some other table, okay. We have to match one of these supposing if statements, one of these case statements. You could have a whole bunch of them. Otherwise, throw an exception, unexpected value provided for table name. So in other words, you're basically saying, if we put in a table name, it had better be something that already exists. So this is what we call a whitelist input validation. In other words, don't give me whole paragraphs of malicious code in place of a table name. So that's whitelist input validation. Now again, like I said, there are whole certifications and whole disciplines on writing Java, on writing SQL statements, on writing safe and unsafe code. But just so you can kind of see for yourself as a pen tester some of these things. Another thing we want to do is we want to escape wildcard characters. Now you see, a wildcard represents something we don't know what it is. Some wildcards are a placeholder for just one character. Other wildcards are a placeholder from 0 to I don't know where it stops. So those are the dangerous ones. And usually a percent sign is from 0 to I don't know where it stops. So we need to make sure that there are limits on those wildcards. We need to escape them. Treat them as text. Here's some Oracle SQL examples. In this case, the percent sign means 0 to who knows how many characters. We could have whole malicious strings in here. So notice that we're saying select name, in other words, give me the name from a table called emp, where ID like. Now, the like clause means it is close to or similar something. In Oracle, we use the word escape. So like something, escape, something else. We're basically saying don't treat this as just text. Do not treat this as anything that is going to allow just who knows how many characters to come in. Here's another example. So escape this right here in a like statement. So the wildcard characters are contained in a like clause. They are not allowed to just, they're treated as text. They're not allowed to just be placeholders for who knows how much stuff. If you want, you can go to OWASP.org. They've got whole cheat sheets and examples on more safe SQL examples. If you study SQL language, after you've taken a few classes and you understand it pretty well, then you can go to this SQL injection prevention cheat sheet, which is meant for developers. Okay, so continuing to defend against SQL detection. No operating system commands like XP command shell. This is something that's in SQL that allows SQL to run operating system commands. Big bozo no-no. Suppress normal error messages and put in customized error messages that will not give away a thing. Make sure that all your database traffic is monitored by intrusion detection or a web app firewall. And make sure that your SQL server and its various services run in accounts that have the least privilege necessary for them to work. Here are many tools to detect for SQL injection. Some are firewall-based, like Snort Rules, Defender, IBM Security App Scan, SQL Block Monitor, Acunetics, Green SQL Database Security, the Microsoft Code Analysis Tool, NGS Squirrel Vulnerability Scanner, that's cute, or NStaler or WSSA. Lots of tools to detect for SQL injection. So those are some SQL countermeasures. Like I said, it might kind of go whing over your head if you are not a developer. That's okay. You should just at least have some familiarity with this stuff because you're going to use the tools that know how to do this.